In-class activity 14A, one-way handover, part 1. First, how to watch this video. Have this lesson note ready, with papers and pencil or pen ready to write. The objectives for this activity. You will understand that determining whether to reject or fail to reject null hypothesis in a one-way handover must involve more than a comparison of group means. The error sum of squares and group sum of squares are statistics that represent the variation within groups and between groups. You will be able to create the null and alternative hypothesis for a one-way handover and discuss variation within and between groups using graphical displays. One, a researcher is interested in comparing the average weight loss over a 12-week period between individuals in 4 groups: diet only, diet and assorted cardio routines 4 days a week, diet and cycling activities 4 days a week, diet and combination of strength training and cardio activities 4 days a week. Explain why a one-way handover should be considered for this situation. Answers will vary. A sample answer is this: the researcher is interested in comparing groups. The researcher is interested in comparing group means of 4 groups. The researcher is interested in comparing group means of 4 groups. Two, write a null hypothesis for this situation. Be sure to define each parameter. This is the answer. The null hypothesis H0 is mu1 equals mu2 equals mu3 equals mu4. Mu1 is the mean weight loss of those who dieted. Mu2 is the mean weight loss of those who dieted plus cardio. Mu3, the mean weight loss of those who dieted plus cycling. Mu4, the mean weight loss of those who dieted plus strength training plus cardio. Now, number 2, write the alternative hypothesis for this situation. Alternative hypothesis. The alternative hypothesis, HA, is at least 2 of the means are different. It doesn't mean all 4 means are different. It says at least 2 of the means are different. Before conducting a formal hypothesis test, the researcher would like to visually assess the data. The box plot and dot plot below compare the distributions of each group, the sample means for each group, as well as the grand mean, that is the mean of all the data values are provided. So we have a box plot, mean number 1, x1, x2, x bar 3, x bar 4, and the grand mean. For the diet, diet plus cardio, diet plus cycling, diet plus strength training plus cardio. And then we have the side-by-side dot plots. So we can look at the diet plus diet, diet plus cardio, diet plus cycling, and then the last group. Based on these graphs alone, does it appear there is a visual evidence to reject the null hypothesis in favor of the alternative hypothesis? Please explain. Answers will vary. This is a simple answer. Yes, the sample means are different from one another, and there is little overlap between the distribution of values. This would suggest the population's means are not equal, and thus we would reject the null hypothesis. So because of that, we would reject the null hypothesis. Suppose at the end of the 12 weeks, the results were different from those presented in problem 4. This alternative result is reflected in the box plot and dot plot below. So we have similar dot plots and box plots here. This is problem number 5. Based on these graphs alone, does it appear there is visual evidence to reject the null hypothesis in favor of the alternative hypothesis? Looking at the graph alone, especially the box plots, does it appear there is a visual evidence to reject the hypothesis, the null hypothesis, in favor of the alternative hypothesis? No, there is significant overlap between the distribution of values. There does not appear to be strong evidence to reject the null hypothesis, stating that the population means are equal. Number 6, compare and contrast the graphical displays in number 4 and 5. How are they similar and how are they different? What might these differences suggest about making a conclusion about the null hypothesis in a one-way ANOVA? Answers will vary, but this is a sample answer. The group means and the grand mean are identical. There is less variation in each of the samples in number 4. In number 5, there is more variation in each of the groups. This suggests that if the variation within each of the groups is too great, that is, there is significant overlap in distributions, then this will likely result in failing to reject the null hypothesis. In the next lesson, we will be conducting the formal hypothesis test for a one-way ANOVA. We will see that the test statistics and p-value are calculated by considering the ratio of variation within each of the groups to the variation between each of the groups. That is, when the variation between the groups is significantly greater than the variation within each of the groups, we will reject the null hypothesis and conclude that at least 2 of the means are different, similar to what we saw in problem number 4. However, when there is a significant amount of variation within groups relative to the variation between groups, like number 5, then we will fail to reject the null hypothesis. We will see that there is a statistic measuring the variation within groups. We will see that the statistics measuring the variation within the groups is the error sum of squares. This is calculated by summing the variation within each of the groups. A statistics measuring the variation between the groups is the group sum of squares. This is calculated by summing the variation between each of the group means and the grand mean, that is the mean of all data values. So for number 7, given the information above about the error sum of squares, which data, problem 4 or problem number 5, do you think would have the greater error sum of squares value? Let's say it again. Given the information above about the error sum of squares, which data, problem number 4 and problem number 5, do you think would have the greater error sum of squares value? Example. Here is a sample answer. There is more variation in each of the samples in number 5. We would expect a greater value for the error sum of squares. This should be explain, not example. Explain. Okay. So for number 8, given the information above about the group sum of squares, which data, problem 4 or 5, do you think would have the greater group sum of squares value? Explain. Answers will vary, but this is a sample answer. The group's means and grand mean are identical in number 4 and 5. This will suggest the group sum of squares would be equal in both situations. This is the end of this lesson. We'll see you at the next lesson.